Now, let's solve example 2.12. So here we have the elastic rubber band. So this is the elastic rubber band. So we have elastic rubber band here is attached to point A and point B. Determine the length and direction measure from A to B. So now we can implement the position vector because we understood that position vector from the position vector RAB, which is we represent the rubber band A to B is with the RAB. So after we determine the position vector, then its magnitude of RAB is equal to the length of rubber band. So next, direction. So direction measured from A to B is the direction can be determined by the coordinate angles of RAB. So coordinate angles means that alpha, beta and gamma. How to do that? So we can have the unit vector UAB. So because the unit vector here, after you establish the unit vector here, so you need to equate the UAB with this relationship cos alpha I plus cos beta j plus cos gamma k. Because this one you can have that the RAB divided by its magnitude, right? So this one in I, so this one is I, and then here you have that RAB in J divided by its magnitude, and then the last one here is the RAB in K divided by the RAB magnitude. Right. So now let's establish the position vector. Step 1. So step 1 here is to establish the position vector. So now what you should do is to determine the coordinate A and coordinate B. So how to determine the coordinate A? So this is our, okay, remember our right-handed. Okay, this is the positive Z, this is the positive X, and this is the positive Y. So whatever direction opposite the positive will become negative. So now for the coordinate A, we need to determine, so here A, so you need to determine what is the X A, Y A, and Z A. Right. So now we refer to the point A. So point A here, from the origin, this is the origin, okay, to the point A. So this is point A, right? So this is the point A. So what is the distance? So here is 1 meter. So the distance, the direction is towards to the X positive. So our X become 1 positive, right? Okay, don't forget this is the unit meter. Okay, next we need to determine what is the YA. So Y, the distance of Y is measured from the origin. Okay, so measure from this origin to this Y. So do we have distance here? No, right? So in YA we have 0. Okay, next is Z. So how about Z? So Z, if we travel from origin to point A, what we have? This is point A. So we have 3. So 3, because it's downward, it's become negative 3. So this is how we determine the coordinate for A. Now we determine the coordinate for B. So now you need to determine the coordinate B. So here B, you need to determine about the XB, YB, and ZB. So what is the XB? So XB here, we travel from origin to this point B here. So we travel in negative side. So what is the length? So it is 2, right? So because of opposite direction, so we have B here is negative 2. Okay, next we travel into the Y. Y exists. So now from this origin to this Y. So what is, we have the distance, right? So the distance is also this one. This is B from origin. So we have 2 meter. Positive or negative? Direction. Positive Y, right? So we have 2 here. And then the last one, Z exists. So now from this origin, we travel to the point B in Z direction. So here we have, from this origin to Z direction, we have 3 here. So positive or negative direction Z is positive. So you write 3. So now we already established the coordinate for A and B. So you can write here. Okay, you can write here that the RAB, the position RAB is equal to what? Plus here, then plus here. So don't forget this is in I, this is in J, and this is in K. So must remember subtraction. So now if we have position A to B, so means that coordinate B minus A. Okay, you got it? Now we have solved the position vector of RAB. So here is the answer. This is the last answer. So this is the position vector RAB that we have established before, that we can have XB minus XA in I plus YB minus YA in J plus ZB minus ZA in K. So here this coordinate we have established before. Then you can have here, so you have negative 2 minus negative 1, negative 2 minus 0, and then 3 minus negative 3. So we solve the mathematical. Then we have negative position vector RAB is equal to negative 3I plus 2J plus 6K. So this is the position vector RAB for the rubber band. So here we can have that from A to B. So this rubber band from A to B, it needs to go negative 3 meter in the X direction, and then 2 meter in Y direction, and then 6 meter in the Z direction. So that is why we can have the position vector for the RAB is equal to negative 3I plus 2J plus 6K. Next, we want to determine the magnitude of the RAB. So this is the magnitude of the RAB. So you can have the square root here. So negative 3 exponential 2 plus 2 exponential 2 plus 6 exponential 2. So you can solve. Then we can determine that the magnitude of the RAB is 7 meter. So we can, this is the length for the rubber band. So we have solved for the part 1. Okay, so now we need to solve the direction. Direction means that we need to get what is the alpha, beta, and gamma. So now we need to determine what is the step 2. We need to determine what is the unit vector AB. So now the unit vector is equal to, this is the unit vector. So unit vector is equal to position vector divided by its magnitude. So now this is the magnitude. So this position vector RAB here. So we have negative 3 divided by 7 in I plus 2 divided by 7 in J plus 6 divided by 7 in K. So don't forget. So here you can solve in decimal. So you can have like this. Okay. So it become like this. Okay. And then now this unit vector can equate with this one. Can use the relationship which is the unit vector AB is also equal cos alpha R plus cos beta J plus cos gamma K. Then you can have that alpha is equal to cosine negative 3 divided by 7 is equal to 115, and then beta is equal to cos negative 1 207 is equal to 72.4. And then the last one, gamma is equal to shift cos 6 over 7 is equal to 31 degree. So we already answer the solution example 2.12. Okay, so you may refer to this figure. So must remember. So this is alpha must from this vector to the x-axis, and this beta is from the vector to y-axis, and the last one is here. Okay, you got it? Next, let's solve the example 2.13. So here, determine the force FAC in Cartesian vector. So Cartesian vector means that so your force should be in I, J and K. So here is given the 420 Newton force along the cable AC. So now this is the cable AC from A to C. From A to C. So here is the force. So how to do this? So here we can apply the method force vector directed along a line. So it's given that magnitude of force is equal to magnitude of F given here 420 multiply the unit vector AC. So how to do that? So the first step, we need to establish the position vector. Position vector of what? RAC. So how to determine the position vector RAC? So we need to determine the coordinate A and coordinate B, because A towards coordinate A and C. So here A and C. So the RAC is what? C minus A. So can you determine the coordinate A and C? Can, right? So here you need to get what is the A. So A here. What is the A and what is the C here? So remember how to determine the coordinate A? So now let's say here. So as usual, you need to know the positive direction of X, Y and Z. So for this case, so this is X positive, right-handed. So this is Y positive, and this is the Z positive. Okay, so now let's travel to determine the coordinate A. So here, okay, we start this from this origin. This is A. So do we have distance? Do we have distance from this origin towards X? No, right? So XA is equal to 0. And then now, do we have distance in Y? Also 0. And then what is the distance Z? Z here. So this is the origin here. So we call Z in. So the distance we travel from origin to A is 6 meter. Positive or negative? Positive. So here is 6. So now let's determine the coordinate of C. So C here. So we use what color? Red color. Okay. So what is X for C? So C, we travel to C, we have X is what? 2 meter. Positive or negative? Positive. So you have 2 here. And then what is X? So this is the, that just now is X, now is Y. So Y here is, what is the distance of Y? This is Y positive. So the distance is 3 meter. Positive, right? So 3 meter. How about Z? So C. C, do we have to travel in Z? So C don't have distance in Z. So Z is 0. So now, can you solve for the position vector RAC? Yes, right. Because to determine the RAC, so RAC is what? RAC. So RAC is C minus A. So you can have that. So in I plus in J plus in K. Right? Then after you determine the position vector, then you can solve for the unit vector. So unit vector is position vector divided by its magnitude. Then you can solve for the force in Cartesian. So here is the answer for the unit vector. So here is the answer for the unit vector. The position vector first. The position vector RAC. So here we have RAC. Here we have the coordinate C minus A in X. 2 minus 0, we have a 2I. And then 3 minus 0 in J, we have 3J. And then 0 minus 6 in K, we have negative 6K. So this is the position vector RAC. It means that from A to C, it's need to go 2 meter in the X direction and 3 meter in Y direction and negative 6 meter in Z direction. Okay, after we establish the step 1, so we can have the unit vector. So next, so in order to have the unit vector, we calculate first for the magnitude. So this is the magnitude of the RAC. So you substitute into this square root. So the vector X is 2 explanation 2 plus 3 explanation 2 plus negative 6 explanation 2, and then you solve, and then you can have 7. So if the unit in meter, so you have 7 meter magnitude. Okay, so now we can solve for this one, unit vector. So this unit vector multiply with this magnitude 420. So this is the unit vector 2I plus 3J minus 6K divided by its magnitude. Don't forget. Okay, this is the answer that we have expressed the force AC in Cartesian vector. So we have 120I plus 190J minus 360K. So this is the method, the step, how to express the force given in Cartesian. You got it? Next, let's solve example 2.14. So we have here two forces are acting on the flagpole with FP is given 560 Newton and FC is given 700 Newton. So determine the magnitude and coordinate direction angle of the resultant force. So now, that is a long step. So the question asks to determine the resultant force and coordinate direction angle. So here you must understood that you need to add two forces to determine the force resultant, and you need to calculate the magnitude and direction of the force resultant. So direction, the coordinate direction means the alpha, beta and gamma. So here First, because of the magnitude is given, so you need to express in Cartesian first. Okay, you remember the step to express the force in Cartesian? So these two forces need to express in Cartesian. So here you have two forces FB. So this is the FB. So the FB is in towards the line of cable here. This is your cable AB. Right. This is your cable AB. And then means that here you can express the FB is like this. So you can have in Cartesian FAB, this magnitude multiply with the unit vector AB. And then second is this FC in the line of this cable A to C here. So you can solve, you can express this FC in Cartesian by this magnitude with this unit vector AC. So here, how to determine this Cartesian? So definitely step 1. So step 1, we need to establish the position vector. Position vector of what? So you need to establish the position vector of this one. RAB here. RAB is equal to what? And then you need to establish the RAC here. So can you do this? What is the next step in order to establish the position vector RAB and RAC? You need to get what? The coordinate. So now you need to have what is the coordinate A, what is the coordinate B, and what is the coordinate C. So what is coordinate A? So you can write here A, coordinate B, and coordinate C. So now A here is, so you must remember the step to determine the coordinate A. So you must refer to the right-handed, which is the X, Y, and Z direction positive. So now A, so A you refer to get A is, what is the X direction in A? So A is 0, 0, 6. 0 means that 0 in X direction, 0 in Y direction, and positive 6 in Z direction. Right, you already expect how to determine the coordinate, right? Okay, next, we need to determine the coordinates B. So B is here. So B is here. So what is your X, Y, and Z? So B, we have 2, negative 3, and 0. Means that you have 2 meter in X direction, negative 3 meter in Y direction, and 0 in Z direction. And next, we need to determine the coordinate C. So now, what is the coordinate C? C is what? So we have 3 in X, and we have 2 in Y, and 0 in Z. So we have done for the coordinate A, B, and C. So can you get what is the RAB and what is the RAC? So RAB is coordinate B minus A. So you solve B minus A. And then the position vector RAC is coordinate C minus A. So you can solve the position vector AB and position vector AC, right? Okay, next, you need to determine the unit vector. Before that, after you get the vector RAB and RAC, you need to determine the magnitude. So usually, we write the magnitude RAB is like this. And then the magnitude RAC is like this. Okay, so after you determine the magnitude, then you can establish the unit vector AB and unit vector AC. Then the third step, you can solve the how to express the force in Cartesian. Here is the answer for the position vector of RAB and position vector RAC, which is RAB is 2i minus 3j minus 6k, in meter, and RAC is 3I plus 2J minus 6K in meter. So now we want to determine the magnitude RAB and RAC. So you just substitute into this equation. So you get the RAB is 7 meter, and then you have RAC, you have also in 7 meter. So now you can substitute, you can divide this vector with this magnitude, and then RAC also with this magnitude to obtain the unit vector AB, then AC. So here you can have the third step, how to express the force in Cartesian. So you can have this one, FAB, the magnitude FAB is 560 divided by, not divide, the multiply with the unit vector AB. So you understood that unit vector is this. And then this is the answer for the FAB in Cartesian. So you need to solve this FAB in Cartesian, then we can have the additional vector. So here FAB is 160I minus 240J minus 400K Newton. And then you do for the FAC. So FAC here is 700, and then multiply with the unit vector AC. So this is the unit vector AC, and then this is the answer FC in Cartesian. So this is Cartesian. Origin Cartesian 300I plus 200J minus 300K. So this one you need to add up and then group in the respective I and J to determine the force resultant, because the force resultant is equal to FAB plus FAC. After you determine this force resultant vector, then we can calculate magnitude and the coordinate direction angle. So here is the vector for the force resultant, which we get it 400I minus 40J minus 1080K. So after we get the force resultant vector, then we can determine the magnitude. So always the symbol magnitude is modulus. FR is equal to, you substitute into this equation, then you will determine this is the answer for the magnitude for the force resultant, which is 1174.5 Newton. So you can round up become like this, force resultant. So now after we get the magnitude for the force resultant, then we can have the coordinate direction angle for force resultant. So you can equate this one divide by magnitude, this one divide by magnitude, this one divide by magnitude, then you can have the alpha, beta and gamma.